What if AI systems could learn to be safer by critiquing themselves, guided only by a set of principles, without constant human supervision? This paper introduces constitutional AI, a method that does exactly that, training models to be harmless through AI-generated feedback, rather than exhaustive human labeling. Building on that intriguing possibility, let's first examine the core problem this research addresses. The researchers identified a fundamental tension in AI development. As models grow more capable, ensuring they remain aligned with human values becomes increasingly difficult and expensive. Traditional approaches rely heavily on human labelers to evaluate every response, creating bottlenecks that don't scale with advancing AI capabilities. So how does constitutional AI solve this scaling problem? The method unfolds in two complementary stages. In supervised learning, the model acts as its own teacher, generating critiques and revisions based on constitutional principles, then training on those improved responses. The reinforcement learning phase takes this further by having the AI evaluate pairs of responses and using those AI-generated preferences as reward signals, completely eliminating the need for human preference labels. This diagram illustrates the complete constitutional AI pipeline. At the top, you see the supervised stage where the model generates a response, critiques it against constitutional principles, and produces a revision. These critique-revision pairs build a dataset for fine-tuning. Below, the reinforcement learning stage shows how the refined model generates multiple responses, evaluates them using AI feedback based on the same constitution, and trains using those preferences as rewards. This architecture enables continuous. Now let's look at what the authors discovered when they tested this approach. The results were compelling across multiple dimensions. Each revision cycle consistently reduced harmfulness as measured by preference model scores. Importantly, the models maintained their helpfulness and didn't resort to evasive non-answers, a common problem with traditional harmlessness training. The AI-generated feedback proved nearly as effective as human feedback, and these improvements became more pronounced as model size increased. This scatter plot reveals the critical trade-off that constitutional AI successfully navigates. Each point represents a model at different training stages, with harmlessness on the vertical axis and helpfulness on the horizontal. The constitutional AI models, shown in orange, achieve superior harmlessness compared to both the purely helpful model and traditional human feedback approaches, without sacrificing helpfulness. The trajectory shows how RL training progressively moves models toward the ideal upper right corner. The implications extend far beyond just efficiency gains. By codifying ethical guidelines into explicit constitutional principles, this approach makes AI value alignment transparent and modifiable. As AI systems become more capable, potentially surpassing human expertise in narrow domains, constitutional AI offers a path to maintain oversight without requiring humans to evaluate every decision. The self-critique mechanisms also provide interpretable reasoning trails, helping us understand why constitutional AI represents a paradigm shift from labor-intensive human oversight to scalable principle-driven self-improvement, a framework that could reshape how we align increasingly powerful AI systems. To explore more cutting-edge research like this, visit emergentmind.com.